Hey guys, today we're going to talk about variance and standard deviation. So last time when we talked about measures of dispersion with all of our quartiles and median and things like that, it helped describe the spread of data so we could see was there a concentration of more data over a certain interval, or maybe there is less data over a certain interval. Now we're going to talk about another measure of spread, but instead it's going to incorporate all of the data values, and it compares those values to the mean. So it talks about how data is distributed is variance, and it's found by taking the mean of all of the differences between the data value and the mean value. The reason that we square it is because, we might be, up by 3 on one and down by 3 on another, and so then those cancel out to be 0. They squared those so that way when we add them together we can see that a little bit better. Okay. Standard deviation is what we tend to use and what you probably hear about the most. He is the square root of variance. Now, in that big list that I showed you at the beginning of the unit with our univariate analysis, there's 2 different standard deviations. We want to use the sample standard deviation, so S sub x. Not this, that's a baby sigma, that's a lowercase sigma, not the sigma sub x. I know I described, hey, this is how we find variance earlier, but we are not going to be finding that with our by hand. We will always be using a graphing calculator. Cool, so let's try a problem. 30 farmers were asked how many farm workers they hired during a typical harvest, and here's the whole list. And we want to find out the mean, standard deviation, how many workers were hired. So we're going to go to our calculator. Okay, I'm going to go to Stat, click Edit. I'm going to clear out both lists. And then I'm going to go ahead and enter that list. We'll meet back up here in a second. Go to Stat, over to Calc, and we want one variable stat, so we'll press Enter. My list is in L1. I don't need a frequency list, so I'm going to clear that and then choose Calculate. All right, so how many workers were hired? So really, we want to add together all of these numbers, right? So the sum of the data set is going to be that second line, that capital sigma sub x. That's going to be 150. So how many workers were hired? 150. And in case you're wondering, remember, this is in your one variable stats in your calculator. Now we want to know the mean number. So our mean is going to be x bar, this guy here on top, and that's going to be 5. So the mean number of workers that were hired was 5. Now we want to find the standard deviation. So we're going to use Sx. Okay, so we got 2.2894, blah, 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 blah. Let's call that 2.29. Good deal. All right. So this time we are going to need a frequency list. So the table illustrates the shoe size of 73 students in a ballet class. Find the standard deviation. We're also going to find a few more things just so we can practice a little bit with it. So we're going to clear this guy out. Go to Stat, Edit. I'm going to clear list 1. And in L1, I'm going to put the sizes. In L2, I'm going to put the frequencies. We'll meet back up together here in a second. Okay, so now we'll go to Stat, over to Calc. We want one variable, stats again. And remember, this time we do want a frequency list. So we're going to have to press second stat to get list and choose L2 since that's where our frequency is. Then we'll press enter. All right, so they want our standard deviation. Our standard deviation, remember, we're going to use S sub x, Sx. So we're going to use, let's see, 1.326, so 1.33. So our standard deviation, got a lot of stuff here, man. So our standard deviation was equal to 1.33. Now I'm going to ask you a couple of other questions. What's the variance? So real quick to remind you, standard deviation is the square root of variance. So if we want to find variance, we're going to take our standard deviation, 1.33, and square it. 1.33 squared. Oh, that did not give me that. 1.33 squared. My mistake, guys, sorry. All right, so that's going to be 1.7689. Let's call that 1.77. Another question I want to ask. How many dancers have a shoe size at least one standard deviation above the mean? So let's break that down. Oh, I need my list again. We'll go to Stat, Calc. All right. So they're telling me here that my mean is 1.178. So let's call that 6.2. 6.2 is the mean. We said that our standard deviation was 1.33. So one standard deviation above the mean means I'm going to add the standard deviation to my mean. So when we add those together, we're getting a little bit over 7.5. So how many dancers have a shoe size bigger than 7.5? Well, the shoe size bigger than 7.5 is 8, and there are 17 dancers who have a shoe size of 8. So how many dancers have a shoe size at least one standard deviation above the mean? 17. All right. Now, we have a coach. They have 2 basketball players, and in the last 10 games, here are the points for each of those players. So now what they would like for us to do is for each player, go through and do a single variable stats, find out total points, mean, median, the range, and the standard deviation. So knock that out for A, and then we'll knock that out for B. We'll meet back up with our one variable stats for A here in a second. So I'm going to find my one variable stats. I'm going to use list 1 for player A, get rid of my frequency list, and then we can calculate. So I have found that for player A, the total number of points, that's the second line here, sigma x, is 150. The mean is x bar, that top number, 15. The median is 15 if we inch down there. The range, remember, is the max minus the minimum. So we'll have to take 17 minus 12 to get 5. And then the standard deviation is at Sx. So 1.49, let's call that 1.5. Now let's do that for player B. I put player B into list 2. So I need to change what list I'm using there. I'm going to go to second stat to get list and choose L2. So the total number of points that he scored, or he or she, they scored was 150. The mean, x bar right there, is 15. The median, we'll have to inch down a little bit, that's 15. For our range, we need to subtract our maximum minus our minimum, so 39 minus 0 is 39. And then the standard deviation, Sx, is 12.1. So, the coach needs a reliable point scorer to start the game. Who should they choose and why? Go ahead and give me an answer. So if you chose player A, I absolutely agree. Because they are consistent. We can see this from the standard deviation. Since that standard deviation is so small, that means that from one game to another, he's pretty much scoring the same amount of points every time. And we can see that by actually just looking at the data. He or she is always making points between 12 and 17, somewhere in the teens. They're always making that many points. But player B down here, we can see their standard deviation is 12.1, right? And we can see just looking at their stats that sometimes they have an awesome game and sometimes they have a terrible game. And it doesn't seem like, every now and then there's an in-between, but it's not very consistent. And we can see that from the standard deviation statistic. Now, if the coach is down by 17 with 5 minutes to go in the game, who should they put in and why? Go ahead and give me an answer, see what you think. So, in this case, if you wanted to say, I would keep A in because they're the most consistent, I could understand that. However, I would put in player B. Because if you're down by 17, you're hoping somebody is going to have a great game. Now, players who tend to have good games, bad games, a lot of times they do well under pressure, right? So you might choose B because they have many high-scoring games. And he's worth the risk. Likely, if player A is in, they're not really changing the game all that much, and they're already down by 17. They're likely going to lose. So, it's worth the risk to put in this other player that sometimes has a great game to hopefully lead the charge for the comeback. All right, I'll see you guys later.